Hi, I'm Mark and welcome to the Anthill. Today we're going to be looking at directed numbers. Now here's the thing, this topic actually isn't that tricky, but it's just one of those areas where students often lose some easy marks in GCSE exams, and it's usually because it's not because of their lack of understanding of mathematics, it's just because they've often picked up one or two of the few common misconceptions with directed numbers. So in this video we're going to look at a countdown of the top 7 misconceptions with directed numbers, starting from 7, working our way to number 1. Okay, before we get into this, have a quick look at this diagnostic starter. Pause the video, take a screen grab. It's a great way of kind of picking up any misconceptions that your children might have. Just get them to have a go at this. At the end of the video, I will go through the answers. Right, coming in at 7, not seeing directed numbers as a movement on a number line. So without this, subtraction of negatives can feel quite abstract. What we need to kind of do is remind our learners about the principles of the number line and where negative numbers, positive numbers, and the direction of where we go when we're adding and taking away. What does that look like on a number line? If we can start to help them visualize what's going on, it helps solve these a lot easier. So the example we've got here, we've got 5 take away negative 2. Immediately I like to put a bracket around it because then that separates the operator by the actual sign, making this a negative number. Okay, so we're starting off with 5. This is our starting point, so we can highlight 5 on our number line. Now a way to start thinking about this change of way is to just think about that the number 5 is 5 places away from 0, or 5 positions away from 0 in the positive direction. So with the number line we've got positive direction, and then we've also got negative direction, which is this side here. So anything travelling to the right we say is positive, and everything going to the left is negative. Obviously if we're adding, we are going towards the right side, and then if we are taking away or subtracting, then we are going to the left side. So once we start to realize this and visualize this, it helps immediately solve these kind of problems that we're getting. Another way you might want to think about it is some learners prefer like a vertical line with 0 in the middle and then going down this way. But just for this example, we're going to stick to this. So as I said before, we need to figure out what's going on with this example. As I said, the starting point is 5. And what we are doing, we are taking away. So immediately the operator is telling us that we're taking away. So we're going backwards. However, when we get to what we're taking away by, we're taking away by a value of 2. But the way we read this sign here is we're taking away in the opposite direction of what we've been asked to do. So it's minus the opposite direction of what we're doing. So the opposite direction of take away is add. So that's why we are going to add 2 more, and that's we're going to get to 7, and now we have solved it. I'm going to do another video on this to make a bit more sense another day. Okay, coming in at 6, contextual reasoning errors. A lot of the time when directed numbers are in a question, they could be part of context, and it might be a worded question. Here's an example. Temperature falls from -3 by 2 degrees. Students rely on intuition instead of applying directed number rules. Again, this is going to strip this back to the we need to strip this back to the number line of applying, well, where is 0? Where is -3 on that number line? And then recognizing if a number drops, it means especially if it's temperature, the number is going down. What generally happens to the confusion is we are starting to blend everyday used words that we would associate with something else, and we're not applying those maths rules about what's actually going on in these kind of situations. And number 5 is misordering negative numbers relative to 0. This one is quite an interesting kind of conundrum that comes up. Students sometimes, in some situations, will go over the motion that -3 is bigger than -1. And the rationale behind this is quite interesting, because they'll recognise that, well, the number 3 is greater than the number 1. Yeah, they are right. However, in the context of directed negative numbers, that's not the case. And again, we can just pin this back down to the simple concept of drawing it on a number line and saying to the learners, right, here's -3 on a number line. Where would you find -1? Because if it's going to be bigger, then it has to be over here. If it's going to be smaller, it's going to have to be over here. So usually they will then obviously identify it, and that helps unpick that problem there. And I think it's that value size that gets the confusion with with ordering negative numbers. In 4, we have students think adding negatives makes numbers smaller. So for an example here, we've got negative 3. We've got negative 3, add negative. Start that again, shall we? Okay, in at 4, we've got students think adding negatives makes numbers smaller. So an example we've got here, we have negative 3, and then we add negative 2. A lot of students could possibly think that the answer for this could be negative 1, and that is not the case. So what is going on here is they think because you're adding, the number is moving towards the 0. And again, the number line, in at number 4 is adding negatives always makes the number smaller. So students sometimes think of if you're adding, you're actually always making the numbers smaller. But adding a negative means that you're moving in the same direction as the sign. So if you start with a negative 2, and now I'm not even getting this right. In at number 4, students think if you're adding negatives, it makes the number smaller. For example, if we have negative 3 and then we add, that is a 3, and then we add negative 2, the answer is not negative 1. But a lot of students fall in for this. Why? What are they doing? They're thinking they're adding, so therefore they're moving. If we imagine that number line going on again, we've got a negative 3 here, and then we've got 0 over here. They think because they're adding, they're moving back towards the 0, and that is the right direction for addition. But we have to remember we've got a negative number in here, so the negative sign tells us we have to do the opposite of what the operator is saying. So it's getting that confusion with the signs that they need to be picking up on. Drilling down to the number line can help with that. So if we had negative 3 and we add negative 2, we're adding, but this tells us to add to move 2 positions in the opposite direction of the operator. So the opposite direction to add would be subtract. So we end up going this way instead, and that's how we end up with actually negative 5. So we'll just summarise that. That would end up being negative 5. Oh, same, I can't do it right. There we go. Okay, let's see what's made into the top 3. So the first one we've got is confusing multiplication division rules. Students often forget, or they will reverse the like signs positive rule. So we'll just quickly look at that. If we have a positive number, we multiply that with a positive number. The answer is going to be positive. A negative number multiplied with a negative number is also positive. A negative number multiplied with a positive number, you're going to get a negative answer. And the other way around, positive times negative, we're also going to get a negative answer. But it's this rule here, negative times negative, this often causes the most problem, where people will put the answer as negative, or they will forget. And very common in algebra questions, especially when factorising or multiplying out double brackets and things like that. I will create another video at some point to explain this reason why it comes out to be these kind of results. But this is the third most common misconception. In at number 2, 2 negative always make a positive. This is such a classic example and a really, really common misconception where students will overgeneralize the rules of multiplication and division and apply them to subtraction. They both, adding and subtracting, multiplying and division, they need to be kept completely separate in that sense. So what we mean by this is if we were to take -4 and then times that by -2, the rule says that multiplying 2 negatives together, we're going to get a positive, and the same for division. So it'd be -4 divided by -2, we're going to get a +2 in that case. But what we find is some students, they fall for this trap of overgeneralizing, where they would apply the same rule here. 2 negatives make a positive, and obviously we know that is not the case. Again, this comes down to really understanding that number line, but really separating and putting into those 2 different boxes. Rules for multiplying and dividing are not the same for adding and subtracting, and then again applying that number line principle too. In at number 1, the most common misconception with directed numbers is confusing subtraction with a negative sign. We're going to break this down nice and easy. So if we have -3 and we're taking away 2, we are going to end up with -5. And another example we're going to have a look at is 5 take away -4. So what I like to do is just put a bracket around the negative number. I didn't put the answer in for that one. That is 9. So what's actually happening here? Well, I'm going to highlight a couple of things just to make it a bit more obvious. We'll do that with the yellow highlighter. I'm going to highlight the operators. So what's happening is sometimes students will confuse the operator sign with the negative sign, which identifies that the number is negative. And that confusion can then obviously lead to mistakes. So what we need to go back to try and remedy this is drawing out that number line. We'll do an example with this one here. So where on our number line is 5, we're going to put 5 over here, and what are we doing? The operator says we're taking away, so we know we're going to go back in this direction, but the way we need to read negative 4 is we are doing the opposite of what the operator is telling us. So we are moving 4 spaces away from 5 in the opposite direction of what the negative is saying, so therefore we're going to go this way, hence the reason coming out at 9. So that is our top 7 most misconceptions with directed numbers. So there's some real simple fixes for this. The first thing is using that number line. You don't need to obviously put it up there forever and ever for every question, and eventually students will then just have it in their head about what it would look like, and they can visualize it. Once that visualization takes over, then there shouldn't be any problems with solving these problems at all. The next thing is really linking this to real life examples like money and temperature. And I'd say the last tip I would say is always separate out those negative signs from the subtraction symbol in the operator. Just to finish off then, we're going to go through and work out the answers to the questions that we had right at the beginning, so you can check and see who you got on. First question is -3 add -2, so we're going to end up with -5. -2 take 2, we're going to end up with -5 as well. -3 take -2 means we're going to go in the reverse way, because the negative tells us the opposite of what the operator is doing. So that means we're going to end up with -1. And finally, 5 take -4. That's going to be 9. Going on to the multiplying and dividing, so -2 times 3 is going to give us -6. -2 times -3 is going to be a +6, because remember, 2 positives or 2 negatives, they're going to give us a positive answer. Remember, that rule only applies to multiplying and dividing. And we've got 12 divided by -3 will be -4. And finally, -12 divided by -3 will be 4. Thanks for watching. Look out for the next videos. They should hopefully be posted up in the near future.